everybody could go to Google Classroom, please, and submit your attendance, whether you're at home or you are in school. So I need you to submit your attendance with that virtual attendance form. Again, you're going to do that every single day, whether you're here or you're at school or it's a Wednesday and we're all learning from home. But that's the district's way of taking attendance for the entire day. I take attendance for myself for a period, and each teacher takes attendance per period. But this is like for the entire school day to represent if you were here or not. So again, if you could please submit your attendance on my Google Classroom page, make sure you go to that page, submit the attendance saying you are here for the day. Ms. Karp, how does it sound back there? Good. Good? So how did it go for everybody here at school yesterday? Pretty good, hopefully. Those of you that are at home, maybe you were missing being at school yesterday and today. I guess the benefit about being at home is that you're done at 2 o'clock on a Friday, or you all have to ride the bus home, I guess, or somehow get home. But I don't know. I think the benefits of being at school definitely outweigh any other positive thing that I can think about of being at home. Today we are going to wrap up section 3.1. So we are going to look at a problem from the book, one of the homework problems from the book that was on my sheet. We have another example to do that's a word problem. And then there's a worksheet that we will be working on that has some challenging equations for you to graph. A lot of the equations have some fractional intercepts. We can still graph fractions. They will still connect. Just makes it a little more challenging to think about and work with. So for the honors level, having those fractions to work with. So I'd like you to take out your homework assignment, wherever that may be. You can see today's homework will be a worksheet. Not all of the worksheet. The numbers are posted to Google Classroom, also on my agenda, as well as this here. I ask that as we go through homework problems, you make corrections to your assignment and then resubmit the assignment. So submit it the first time and then I can see the corrections. Lacey, I'm not calling on you, but Lacey does an amazing job of like submitting it and then she just submits her corrections, which awesome. Thank you. Totally appreciate it. Like fantastic job. And some of you other people do that as well, but I know Lacey always just submits a second attachment with the corrections that she may have made on her homework assignments. And that's all you have to do. Just submit a second attachment to show that you've had corrections to any problems maybe we discussed that you got wrong. So I thought we would look at the word problem because I guess nobody likes word problems. I don't know why. No, we didn't get to go over the word problem yesterday, but yes, we have done linear word problems in chapters 1 and 2. So now we're just writing 2 word problems. But it's the same format or the process, that kind of thought process that you would use. So the book that I copied this from that I have posted online, I do have an online version, is actually the Texas book because Pennsylvania doesn't post theirs online. So I didn't steal it from Texas, borrowed it. I mean, it was posted online. So like if you post it, then everybody has the permission to use it, right? But it's the same book as ours. It just says Texas instead of Pennsylvania. But anyway, you worked 14 hours last week. You earned a total of $96 before taxes. Does anybody have a job? I know a lot of you are 9th graders. You have a job. Do you get taxes taken out of your job or are you paid like under the table by somebody you babysit or? Yeah, that's kind of nice because then you're making that $96 and you don't have taxes taken out. The more money you make, the more taxes are taken out, which is kind of evil. I'm learning that as I start making more money since I've been teaching, it seems like forever. Yeah, lots of taxes come out of my paycheck. So You earn a total of 96 bucks before taxes for 14 hours. That doesn't seem too bad. Your job as a lifeguard pays $8 an hour, which I'm pretty sure the lifeguards at my pool make more than $8 an hour, and they probably do less than this person would do. They're not very good lifeguards. And I have that on a recording, so hopefully none of the lifeguards will ever watch my recording. And your job as a cashier pays $6 an hour. Now, I don't know, that's pretty low, and I believe the Pennsylvania hourly rate is at least $7.50. You have to at least make $7.50 for minimum wage. I know Aldi chart, like I think you get $13 at Aldi when I see the sign outside. So $6, that seems pretty minimal. I'd say get rid of that job and find a new one. How many hours did you work at each job? So our goal is to figure out, you know you work 14 hours. How many hours did we work at each job? That's what we're trying to think about here. So when you're writing an equation, you have two jobs. One job has to be job X. The other job has to be Y, because we're trying to think about how many hours we worked at each job. So that's key there. So at each job. So X, my first job it said was a lifeguard. So I'm going to say number hours lifeguard. Try and squeeze that in there. Y would be then the number of hours as a cashier. So I've defined my variables. I know what X and Y mean. And if you're not sure about the variables to use or what you're trying to solve for, usually the last part, that last question, kind of gives you an idea of what you're looking for in this problem. So how many hours did you work at each job? So hours and job have to go together, hours per the specific job. All right, so we know how much we make per hour at the specific job, and we know how long we worked, total of 14 hours. So we can try and make two equations. Remember, this is a system of equations, so I need to come up with two. Can anybody give me one? Alyssa.
X plus Y equals 14.
And what does that represent?
No matter what the number of hours has to equal 14.
Yeah. So if X is the hours at a lifeguard, Y is the hours of a cashier, together my two jobs, together means add, must be 14 hours. So the two jobs must equal 14 hours. Alyssa, did you get a second one?
Yes,
What'd you get?
8x plus 6y equals 96.
And that equation deals with what, Alyssa? How much you make. So you have the total hours worked in the first equation, the amount you made in the second equation. It's almost like we're grouping our like terms. I'll say like terms with quotes around it, the like quantities together. So the first equation has the hours worked. The second equation has the money we made for those hours worked. And then you can solve this. Alyssa, how do you solve it?
I got stuff on
Okay, so how would you solve this? Like, how could I solve this?
I
Gabby.
ended up using for the 8x plus 6y, I ended up plugging in 0 for the x and for the y.
So you plugged in 0 for the x, 0 for the y, and then what'd you find?
I got the answer.
So, okay, so you found those intercepts?
Yeah.
Yes. So she found plugged a 0 in for the x and a 0 for the y. She found the intercepts. What else could we do? You could graph it. I mean, we were graphing yesterday, so you could graph it. There was graph paper attached that you could have graphed it on. You could have graphed it on Notability. The graph paper in Notability is awesome. I even just like writing, I feel like it keeps things organized. Another thing you could have done was maybe just get y by itself and solve for y, because you have to get y by itself in order to graph it. But we could have gotten y by itself and then gotten y by itself to graph this one. Does anybody know if I divide by 6? 96, does that divide by 6? 16. So -8 6 becomes negative 4/3, and then 16. So I know 90 divided by 6 is 15. So yes, 96 divided by 6 is going to be 16. So then I would graph those two. That's probably how I would have approached it. Gabby, your reasoning was fine as well, as long as you have some kind of reasoning behind it. So graph them. Yes, you're going to need a graph that goes up to 16 because the y-intercept of this first one was 16. And find out where they intersect. Questions?
So,
Brooke?
if you are, so how can that be negative? Because like you can't have a negative amount of money.
Correct. What's negative in my problem?
It's slow.
The slope. It's okay for the slope to be negative. That doesn't really represent the amount. Like the question is saying, what is the amount of hours? It doesn't mean where they intersect is going to be negative. So yes, our equation is going down when it's in y equals form, but we would be looking at like a chunk of time. So technically this is saying like the more hours you work at one job, the less hours you would work at another job. Because the hours can't both increase because my total amount of time is 14 hours. So that's why the lines decrease, because if I work 14 hours at one job, then I would work 0 at the next job. So they will go down, again, because they both can't be a high number because the max is 14. Does that make sense?
Yeah, thank you.
And again, where they intersect is going to be positive. They're going to like intersect in that positive first quadrant. Other questions? Good questions. So I'm not going to graph that. Let's look at the 36, just thinking about how to come up with the equation for 36. And then we're going to look at our own set of equations. As I said, we'll look at a word problem. During one calendar year, a state trooper issued a total of 375 citations for warnings and speeding tickets. Of these, 37 more warnings than speeding tickets, or there were 37 more warnings than speeding tickets. How many warnings and how many speeding tickets were issued? So if I look at that last sentence, or actually it's a question, that's where I can kind of figure out what we're talking about for X and Y. How many warnings? How many speeding tickets? Ms. Carp, have you ever gotten a speeding ticket?
I have not.
I have not either.
Mm-hmm.
Mr. Kane has, but I have not. So speeding tickets and warnings, X, Y, X warnings, Y speeding tickets. So now I need to kind of think about writing those equations again. So going back and looking at this sentence a second time. A state trooper issued a total of 375 citations for warnings and speeding tickets. So Lacey, if we wanted to use that first sentence, how could we write an equation for that first sentence?
375 equals X plus Y.
Yeah. Again, that's my total of the two types of tickets this state trooper issued in a whole year. So it's not a month, but it's a year, 375. Total citations for warnings and speeding tickets. Now the next one's a little different. It says of these, there were 37 more warnings than speeding tickets. So we have to think, how can I write that as an equation? 37 more warnings than speeding tickets. Cody, how would we write that?
X minus 37 plus, like in quotation marks, then plus Y equals 375.
Actually, you know what? You are combining the two together. So I already have a number that includes the 375. We don't need to include the 375 in the next one. I think you were trying to make maybe one equation instead of two separate. Sorry, let me think. Jaden.
So would it be X, Y, wait, sorry, I'm trying to figure out if this is the question right. So it'd be Y equals X. Plus 37?
So 37 more warnings. So 37 more warnings compared to speeding tickets. So Cody, I think you were just combining both equations together to solve, which would be fine. Trying to just write two separate equations. Again, set them equal to y and graph. This one's a little harder to graph because it's up to 375. So as I said, we're going to do one more of these today. So you get a little more confident about solving word problems so that we have a couple examples to look at. The word problems will not go away. So hopefully the more we do, the better you'll get at understanding what you're looking for with the pieces. I know in geometry there aren't maybe quite as many word problems like this. Yes, geometry has word problems dealing with shapes and dealing with angles, but not necessarily the algebraic pattern of a word problem. Thinking about what do the two variables represent in the problem. And that's kind of the key when you're writing word problems. So we will continue every single section to look at word problems so that you hopefully get a little more confident with them. So what I'd like everybody to do, again, take a picture of that, submit it to Google Classroom if you made some corrections. Just re-upload that, resubmit. You're allowed to resubmit assignments. You can do it now, you can do it later, but please make sure you do get a picture of that so then you can resubmit those whenever you finish your assignment. We are going to wrap up this section talking about another word problem. We're going to graph this one together so that you can see how they will graph. Tonight in your homework, yes, you're going to have a word problem. And I think it's like one word problem with 2 or 3 parts to it. And it kind of takes you piece by piece to like get you to think about the parts that create our equations, our systems of equations. So when you're ready, if you could take out that chapter 3 packet, wherever you have it, whether it's on Notability on the iPad or if you have it on separate paper. Jaden, I love the hot pink paper over there.
Thank you. Yeah, it was not even supposed to be like that. So, like I said, my dad's a dance teacher, so they had to print out like colored football tickets for like yesterday night and tonight. Well, like my dad printed it out by accident while they were printing the colored tickets.
So it kind of went in with the tickets, huh?
Yeah, so but it's okay. Oh.
Yeah, looks good. So there is a final example dealing with like the word problem example, and then there's 2 checkpoints. But we're going to look at this word problem. Yesterday we talked about systems of equations, graphing 2 equations on the same axis. We call that the Cartesian plane, the same plane. So the word problem here says we want to write and use a linear system. So again, the key thing is I should have 2 equations when we write this. At an ice cream shop, one customer pays $9 for 2 sundaes and 3 milkshakes, or 2 milkshakes, not 3, 2. So $9 for 2 sundaes and 2 milkshakes. I'm pretty sure I cannot go to Brewster's or Cool Cones or Dairy Queen for the 4 of my people in my family and only pay $9. This seems like a steal. Sundaes and milkshakes, $9. A second customer pays $13 for 2 sundaes and 4 milkshakes. How much do each sundae and milkshake cost? So you can see here that this is a verbal model, and a verbal model is kind of the words. What am I trying to solve for? What should we be thinking about? Do you need to write a verbal model? No. But this will be like your logical reasoning process when you're trying to write an equation. So what do I need to think about when I'm writing an equation? This equation is a little different because we're talking about 2 different customers. So we're talking about one customer and what they order, and then we're talking about a second customer. So when we write the equations, we're going to write an equation for customer 1 versus customer 2. So the way this equation is written, we have the total cost, the number of sundaes, and then the cost per sundae, the number of shakes, and then the cost per shakes. So we need to decide first, what do we want X and Y to be? How much do each sundae and shake cost? Well, that's my question that I need to answer. So I would say let's make X be the number of sundaes And you might as well make Y be the milkshakes. When you have a word problem, you need to define your variables. That means, what are they talking about? What do they mean? So when I write this equation, the number of Sundays will be X. And actually, I guess it's not the number of Sundays, but it's the cost. We're trying to figure out the cost. My fault. I'm gonna put dollars with milkshakes. They tell us how many Sundays we buy. My apologies. And then the dollars with the Sundays. So my cost is going to be X for Sundays. My cost is going to be Y for my milkshakes. How much do they cost? So Ava R, if we want to write an equation for customer 1, how can we write an equation for customer 1?
So they pay a total of 9, so it would be 9 equals 2x plus 2y.
Yeah. So we bought 2 Sundays for a certain amount of money and 3 shakes. And then Julia, how about equation 2? Customer 2, how much did they pay?
13,
For how many Sundays?
2,
And
4.
4 milkshakes. Question?
Should that 3 be a 2?
Yeah, it should be. Apparently I have a hard time writing. Thanks for catching it. 2 Sundays and 2 milkshakes. All right, see if you can get these equations in Y equals 4. And we're going to try and graph them. So there is a nice little graph shown below so that you can kind of see how you would make a graph. So Y equals 4. This is where you get the heebie-jeebies because I'm noticing when I divide, I'm going to have a fractional y-intercept. We can still graph and work with fractions. As I said, some of the homework problems tonight, you will have some fractional y-intercepts. So taking the x to the other side and then dividing by 2. Notice this is also a negative slope. Again, because there has to be a maximum amount that I can kind of work with, my maximum amount I'm spending. Yes?
Why in this equation, like when you're moving 9 to the other side, is it like plus, like?
Well, I didn't, like I'm still moving this to the other
Oh,
side.
you're moving that.
Yeah, I just totally flipped my equation.
Yeah.
I'm sorry. So I just said 2x plus 2y equals 9. I mentally just flipped it at the same time. No, it's okay. I like seeing y on the left.
Yeah.
So I just kind of flipped it at the same time here. So here's my y equation for customer 1. Customer 2, so again, I'm mentally flipping this equation. Making the variables on one side, the number on the other. So I would have 4y, negative 2x plus 13, and then divide by 4. So a negative half, and then 13/4. So here is customer 2 and customer 2's equation. If you're all right solving the equation with the number on the other side, you can keep it like that. I just like seeing y equals mx plus b. That's an OCD thing for me. I like things in a certain way. X always on the left, y always on the left. So why don't you try and graph this? Gabby Snyder, what would the y-intercept be for the first equation for customer 1 here?
9 halves.
And what is 9 halves? 4.5. Yeah, so we're going to go up to 4.5. So it's in the middle of my box, and then I'm going, the slope is negative 1, so down 1, right 1. My points should all be in the middle of a box. Notice it's just the positive axis here because you cannot have a negative number of Sundays. You cannot have a negative number of milkshakes. Their cost can't be negative. So that's why I only have positive X values, positive Y values. Anytime we have an actual real life application, we don't have negative amount of money. We don't have negative amount of objects. So we really should be just graphing in that first quadrant. My second, here's customer one, I guess I should graph them in the other colors. That's all right. 13 fourths. What is 13 fourths? As a decimal, what is 13 fourths? Ella, do you know? 3.25. So it's going to be closer to 3 than it is in the middle. And now we're going down 1 and over 2. I guess it's a little less than that. So down 1 and over 2. Yeah, it should be underneath there. Down 1 and over 2. So both of them decrease. Again, it's okay that that's decreasing. We're decreasing because I can only have a max amount of money that we're charging. So let's graph the equations. We have a nice graph here. The last part says the lines appear to intersect at about the point blank. Now, depending how accurately you graph them, this answer will be a little easier to find. You have a calculator that you can also plug in to find that intersection. But where does it look like they're approximately intersecting at? Brooke, what would you say the approximate intersection would be?
I don't completely know if I graphed this right, but it looks like 2.5 and 3.5.
2.5 and 3.5?
Oh, yeah.
She says, I'm a little afraid to say anything. 2.5, 3.5. Cody, what do you think?
I had a 2.5 and 2.
2.5 and 2. So I don't know, like it's hard for me to see with mine over here. He said he has 2.5 and 2. So maybe he has his crossing like up here. How do we know? How can we check? Go to your calculator. Yeah, so take out that calculator. Cody says, I love using that calculator because it makes sure everything is correct. So especially when you're graphing and you're looking for an approximate value, it doesn't cross in an exact ordered pair. Sometimes it's hard if you're not being exactly precise. You don't pull out that ruler to help you graph. It is hard to kind of get an idea because mine looks like, maybe mine was around 3.2, but that might not actually be the exact cost. So plug them in your calculator. If you need help with the calculator, please let me know. They're both in y equals form already. So you're plugging them into the equation, into y equals. Your graph looks really nice. You guys can make those straight lines when you're in Notability. And then go to this intersection point. So second trace, second calculate, find that intersection point. Because we're talking about, what are we solving for? Because we're solving for cost.
Oh, so good.
Yeah. So because we're solving for cost, it would be 250. So Cody was correct. Checking that with the calculator, though, helps us make sure that we are correct. And it's okay to have decimals because we're talking about how much they cost. So the question says, how much do they cost? What is the cost of the sundae and a milkshake? That was our actual question. So the sundae costs $2.50. That's the cost. The milkshake is $2. So we can keep it as a decimal because we're talking about money. I think some of you graphed it, if you use Notability and you got that straight line on Notability, some of you got that point to be pretty close to being, looking like 2.5 and 2. Mine is a little off. Does anyone have questions? Anyone have problems with the calculator?
I had a problem last night. I tried to this problem for the children.
Okay, so because this number is so high, because this is your y-intercept. So when you go to the window guy, we need to change that y value. I would say maybe 400. Because this is where your graph starts. So it starts way up on the top with the y-intercept, and it's so big. And you might need to change your x value and make it bigger as well to get a big graph. Anybody else have questions?
So this is like back up to the top, but the only reason we called this S and this Y because this was listed first.
Yeah.
Okay.
Does it matter? No. So that was a good question. Like when you're deciding which is X and which is Y, I usually go with what is listed first and make it X, what's listed second and make it Y. Does it actually matter? No. As long as you're making one of them X and one of them Y, your ordered pair would just be flipped. So you would have 2, 2.5.
But it would still be the
It
same.
would still represent the same thing. Yeah. I'll be over right in a minute, Julia. All right, so I'm not going to do the other 2 graphing problems because I wanted to focus more on the word problem aspect today. If you go to Google Classroom, you will see a worksheet posted for today. The worksheet that's posted for today has actual graphs on it, but the graphs are really tiny. So if you want to use the graphs on the worksheet, you can. But you can also use graph paper that is attached to the assignment, or you can use the Notability graph paper. Oh, here, yeah, let's go back to your equation. This should be, what do you have here? -1/2, so just -0.5. You're slow. So again, you can go to Google Classroom. So you're going to Google Classroom. The assignment is posted for today. We have about 10 minutes. You can start that homework assignment. If you're at home, again, you go to Google Classroom. The homework assignment is posted. There's about 10 minutes left in class. I guess more like 13 because of the homeroom time. It's a worksheet. You're doing 2 to 16 even, and then 17 to 20, the last group of problems. So here's what that worksheet looks like. So the first 3 questions, again, really you're just doing 2, you're doing even there. You're going to classify the system as consistent and independent, has 1 answer. Consistent and dependent has many answers, or inconsistent. And then the next group of problems, that's where you are graphing them. And as you can see, the grid is a little small. You can zoom in though. Again, if you shove this to Notability, push it to Notability, you can zoom in. Make sure you're noticing if the graph is counting by 2s or if it's counting by 1s. How is it labeled? So that's something to look at. But definitely get started on this worksheet. If you have questions, please ask. Next week, we're going to continue to solve systems, but we're going to solve them algebraically.